Hey, let's make a key for this quiz. A colony of bacteria grows according to the law of uninhibited growth. N is equal to 300. 300 is important. That's our initial amount. E to the 0.45 T. That 0.45 is going to be our growth rate, and because it's positive, it is growth. If it was negative, it would be decay. Where N is measured in grams and T is measured in days. So the days is important. Determine the initial amount of bacteria. Well, that 300 will be your initial amount. Imagine putting a 0 in for that T. That 0 is going to change your 0.045 to 0. And then you're going to have an E to the 0 power, which will return a 1. And then 300 times the 1 is 300. So when it's in that structure, just know that 300 is going to be your initial. The growth rate is that 0.045, so 0.045. But I want you to say that means you have a 4.5% growth rate. What is the population after 5 days? Well, to figure that out, we'll replace the T with a 5. And we'll just type that out on our calculator. So 300 second E, raise that to the so 375.6968. And that's in grams. When will the population triple in size? Well, we started with 300, so when does it become 900? Now, you don't have to know the 900 or the 300. The triple is the key word. As soon as you divide your A sub 0 over to the other side, you're going to get 3. We'll take the natural log of the two sides, just so I could take the power and put it in line. The natural log of E, I'm not going to write that because we know that's a 1. And I'll divide the natural log of 3 by the growth rate. Natural log of 3 divided by, and that gives me, 24.4136. And that is in days. A colony weighing 100 grams grows according to the law of uninhibited growth. If the number of bacteria, we got to figure out a growth model. So A is equal to 100 E to the KT. That gets me started. And it says that the bacteria doubles in 3 hours. So 200 is equal to 100 E to the K times 3. And time is in hours for this problem. I'm going to divide the 100. I get a 2 for double. I'm going to rewrite the K times 3 as 3K. Natural log of the 2. Pull the power out because I did the natural log of both sides. Natural log of E goes away. So that will be our K value. So our K is 0.2310. And I'm going to store that so I have that forever for this problem. So my model how long will it take for the population of the original colony to triple? So we started with 100. So when does it become 300? I'm not going to write the K. I refuse to write decimals over and over. I'm going to divide the 100. So the key there is to the triple. Natural log of the two sides, so I can pull the exponent out. And then I'll divide in order to find time. The natural log of 3 divided by my K value. And that's why I stored the X. 4.7549. And that is in hours. What is the size of the population after 1 day? And we replaced our T with 24, and we know the K value, we stored that. So 100 e to the K value I stored as X times 24. I changed it to 24 because 24 hours in a day gives me 255999999. So I'm going to make that 25,600. And this is in grams.